Hello guys, welcome to my YouTube channel. In this lesson, we are going to learn how to solve quadratic inequalities. And I have two examples here to help us learn this skill. All right, I know that while working on this lesson in the classroom, a lot of students were a little confused and they can't see what we're trying to do here. All right, I'm just going to keep it simple. First, what I can do here is it favors to be able to factor. Okay, you need to learn how to factor quadratic expressions. All right, you can use box method, whatever method you can use to help you factor. Okay, now you don't want to use quadratic formulas and all this completing the square stuff. You don't really need that. So that's expression, or the expression on the right and left hand side, is simple enough to factor. So of course you have this and you have that. You have greater than equal to 0, and factoring that would give you x minus 5 and x plus 2. So of course I have videos on how to factor quadratic equations. Go ahead and check them. I think if you check my YouTube channel, you're going to see on the playlist where I have this scaled a breakdown on how to factor something. All right, so let's go. So from here, you have to have two cases, okay? Now, greater than 0, this is how you would solve. This is the procedure to solve it, okay? I'm showing you the procedure, okay? So you're going to have two cases. So you have case 1 and case 2. Just like the way you solve absolute value inequalities. So this is what you're going to do. So since you have greater, so you're going to introduce x minus 5, okay, and set it greater than 0. And also the second part, x plus 2, also set it greater than 0. That's your first step. And your second step will be this. You do the opposite, okay, just like you do for absolute values. So it will be x minus 5 is less than 0, and x plus 2 is also less than 0. This is from the understanding of positive multiplied with positive, all right, equals to positive, and negative multiplied with negative equal to positive. Okay, so what does inequality here represent here? This greater than 0. Greater than 0 means positive. Okay, so I'll just do plus VE. Okay, so it means that you're multiplying two numbers together. Those numbers in the parentheses, you're multiplying them together to get a number greater than 0. And for us to have this happen, they have to be both positive. And in inequalities, greater than 0 means positive results. Okay, so now that to get positive results, you have to multiply them and setting each one greater than what? 0. And also reverse them, each one less than 0. That's how it makes sense algebraically and logically to have this setups. All right, so now to solve this problem here, I will just add 5 to both sides. I'm going to add 5. So I'm just going to do everything one time. I'm going to add 5 here, okay, and add 5 over there. I'm going to subtract 2 here, subtract 2 here. You're adding 5 and adding 5. You're subtracting 2, subtracting 2. I'm just trying to finish this very quickly because of time. So cross this out. You have x will be greater than 5. And here, you're going to cross this out. You're going to get x is greater than negative 2. And on the case number 2, you're going to have x is less than 5. And then you're going to get x is less than negative 2. So here's what you're going to do. So you're going to find a way to combine these two and find a way to also combine them. Okay, x is greater than 5 and x is greater than negative 2. What does this mean? So it means that now you want to look for a single interval that captures this information. All right, so let's look at this. X is greater than 5. Does that already mean that x is greater than negative 2? Of course, yes. So if x is greater than 5, it means it's already greater than negative 2. So which means you can just choose x is greater than 5, period. So x is greater than 5 would represent both information because you have and, that's the conjunction. And then the second situation is or that. Okay, now you also can do the same here. If x is less than 5 and x is less than negative 2, negative 2 is more, it's lesser than 5. So in that case, you have to choose this, okay? So you choose x is less than -2. Okay, this is the result you get. All right, so this is what you can do in this situation. So whenever you have a greater than symbol, you have to have a union. Remember when we did absolute values, it was the same. For absolute value, absolute values and then quadratics, they kind of have similar graphs. You understand? So they will reflect. You can reflect them. All right. So they are symmetric. So here, the solution here will have will have a gap, because you can see that x is greater than 5, it goes to the positive direction, and x is less than -2 goes to the opposite direction. So which means that if we want to do this, that means we can just just sketch a graph like this and like that, and you can verify this on decimals. Okay, so -2 is right here and +5 is around here. And when you say x is greater than 5 and it's a less, so you have to use dashed lines going that direction, and it shades all the way to the right hand side, all the way to the right hand side. And this is x is less than -2, which means you can start from -2 and just break it down. See what I'm saying? And then you shade all the way to the left. So when you graph this in decimals, you're going to see your results that are true. Okay, this is what you're looking for. So that means if you want to write your answers, it'll be, because you have -infinity, comma -2 on the left, union on the right. So this symbol is called union, okay? Just like letter U. Okay, and they have 5 to positive infinity. So this is how you solve this problem. Let's go ahead and try the second one. So for this problem here, we have less than or equal to 0. So we're expecting that our answer could be combined. All right, so we're looking for a type of graph such that it is shaded in between. That's how your solution set should look like. It can be compared directly to the graphs of absolute value inequalities. Okay, so, all right, so this is what we're going to do. So let's get started. Again, it helps to know how to factor. You got to factor this. Okay, to factor that, so we're going to look at 3x minus 1 multiplied to x plus 2 less than or equal to 0. Again, if you want to know if this is the correct factor for the expression, you just got to multiply them and, just distribute and see if it gives back 3x squared plus 5x minus 2. Okay, so we hope it works. It works like that. So that's what you're looking for. Actually, it works. So now we're going to have case 1 and case 2 as well. From here, you have case 1, then you're going to have case 2. Let me just separate it quickly. For case 1, this is what we're going to do here. The strategy here is, since you have less than 0 means negative, okay? And which means you're multiplying two numbers together to get a negative output. So that's how you should think about it. So in order for this to happen, it means that each piece here, this has to be negative and the other has to be positive. And you can switch it later. So you cannot have negative and negative being multiplied to get a negative result. But what you can have is, maybe take the first one, -1, and set it less than 0, and then take the second one and flip the sign. That's how you do it. This is the strategy to do it. Okay? On the case 2, you'll do 3x minus 1. You will flip the sign as greater to 0, and then you do the second one. It will be x plus 2, and then you flip the sign to less than 0. So you change the signs. Okay? That's how you do this. That's the procedure to do that. And if you think about them, they make sense logically, okay? And algebraically. All right, let's see what we can do here. Here, all you gotta do is here add 1 to both sides. Subtract 2 and subtract 2 to both sides. Add 1, subtract 2, subtract 2. Kind of repetitive, okay? All right, so what we're going to do here is cross out, cross out, cross out, and cross out. So we have 3x is less than +1 here. And so the conjunction here is and, okay? You have to tie them up because it's multiplication, so it's and. All right, and in the first case and second case you have or. in between them. All right, so this one here will be x is greater than or equal to -2. And we'll go over here, the signs are switching. So we have 3x is greater than 1. And here we have x is less than -2. You can just see how they're switching signs. So from here, I'm going to divide both sides by 3. Divide by 3, divided by 3, you're dividing by 3, dividing by 3. So because we're already done with this one, so we don't have to keep solving for these ones. We're done with those. Now cross out, get x is less than 1/3 and x is greater than or equal to -2. Here you have x is greater than 1/3 and x is less than -2. All right, so now, just like we did here on the first example, we're now going to have to select two solution set, okay? Two of them. And they can happen here or they can happen here. We can combine. If not possible, then we will have to look for the best way to combine them. Now, looking at this first statement, okay? X is less than 1/3 and x is greater than -2. Does this make sense logically? Well, what you can do is to draw. And it's a serious condition. And means it has to happen. Otherwise, it won't work. All right, so that's why we're able to combine this result here to get a single result. So we have to be able to combine them. We don't want a situation where they go separate directions, okay? So this is what we're going to do here. So we have 1/3 here. This is the x and y. So you have 1/3, which is your x and y axis. Let's do x and y axis here. Just do that. So this is your 1/3, and that's your -2 right here. So for 1/3, it says x is less than that. So less than or equal to. So we can just go in this direction. And for the second, we have greater. Okay, so we go from there to the other direction. So you can see how they meet, right? So this will be a solution set. But if you go to the second one, the second case, and draw, let's see what that's saying. See if we can choose them or not. This is your y, this is your x. And looking at this, it says x is greater than 1/3, which means 1/3 is right here, right? 1/3, and -2 is right here. And greater means all the way to the right. And lesser means all the way to the left. You can see that they do not combine, and you have and. And is in between them. So there's no way you can combine a situation like this one. It will be a contradiction to say x is greater than 1/3 and it is less than -2. We'll be like, what are you talking about? How can the same number be greater than 1/3 and be less than -2? But we can say that a number is not up to 1/3, but it is more than -2. So which makes sense here. So we're going to choose this and not choose the second solution. So the solution set we have here will be x is less than 1/3, but it's greater than negative that. So we're going to start with -infinity. All right. We can do -infinity. We cannot do infinity here because it did not go on and on forever. So it will just be like that. Square brackets, because we have equal signs, which means it contains the endpoints, and 1/3. This is how you do it. You got to use square brackets here because of the greater, less or equal to that we have from the beginning. And that's why when you graph this, it will have a solid. It will have a solid line here. On decimals, you see a solid line passing through, and it will shade in between. It won't be like this. All right, I hope this helps. It's not very easy. It's tricky. Okay, another way there are other ways you can do this, and you have to look at the textbook as well and go over some examples to get better. Come back another time for more. Okay, thank you very much.